Estimating the amount of wire in a 3,000 square foot house involves considering several factors, including the layout, the number of circuits, and the types of electrical devices being powered. Here's an approximate breakdown of the different wire gauges commonly used and their estimated lengths. Firstly, 14-2 wire, which is often used for lighting circuits and general purpose outlets, typically accounts for a significant portion of the total wiring. In a 3,000 square foot house, you might find anywhere from 8,000 to 10,000 feet of 40-2 wire. Secondly, 14-3 wire, which is used for three-way switches and sometimes for split receptacle circuits, is used less extensively. Expect to see approximately 2,000 to 3,000 feet of 40-3 wire. Thirdly, 12-2 wire is commonly used for kitchen outlets, bathroom outlets, and other high-load circuits. The estimated length of 12-2 wire is around 4,000 to 6,000 feet. Fourthly, 12-3 wire, similar to 14-3 wire, is used for specific switching configurations or split-wide circuits requiring a neutral. The estimate here is about 1,000 to 2,000 feet. Fifthly, 10-3 wire is typically reserved for larger appliances like electric stoves, dryers, or smaller air conditioning units. You might find around 500 to 1,000 feet of 10-3 wire. Sixthly, 8-3 wire is used for even larger appliances or subpanels, with an estimate of 250 to 500 feet. When you add up these individual estimates, the total amount of wire in a 3,000 square foot house can range from approximately 16,250 to 22,500 feet. Keep in mind that these numbers are estimates and can vary significantly based on several factors. Firstly, the layout of the house is a critical determinant. A more spread out house requires longer wire runs compared to a compact, multi-story design. Secondly, the number of electrical devices and circuits installed is also crucial. A house with many lights, outlets, and appliances will naturally require more wiring. Thirdly, the electrical system design, including the placement of the electrical panel and the routing of circuits, affects the total wire length. Fourthly, local electrical codes and standards might influence the types and amounts of wire used. It's important to consult local regulations to ensure compliance. Fifthly, special purpose circuits such as those for HVAC systems, security systems, or dedicated circuits for home theaters are not included in these estimates. These would add to the total wire footage. Sixthly, the skill and practices of the electrician can also play a role. Experienced electricians may optimize wire runs to minimize waste and reduce the overall amount of wire needed. When purchasing wire, it typically comes in spools of 500 or 1,000 feet. The actual number of spools required will depend on the specific footage needed for each wire type, and it's always a good idea to slightly overestimate to account for waste and unexpected changes during installation. To ensure accuracy, it's best to consult with a qualified electrician who can provide a more precise estimate based on the specific plans and requirements of the house. Estimating wire footage for an entire house involves understanding the purpose and application of different wire gauges. The wire gauges mentioned, such as 14-2, 40-3, 12-2, 12-3, 10-3, and 8-3, refer to the American wire gauge, or OG, standard. The first number indicates the gauge of the wire, and the second number indicates the number of current carrying conductors within the cable, excluding the ground wire. Firstly, let's explore 40-2 wire. This type of wire consists of two current carrying conductors and a ground wire. It's commonly used for lighting circuits and general purpose outlets rated at 15 amps. According to the National Electrical Code, or NEC, 14-gauge wire is suitable for circuits protected by a 15-amp circuit breaker. The wire is typically insulated with a thermoplastic material such as polyvinyl chloride or PVC, which provides electrical insulation and protection against physical damage. When installing 14-2 wire, it's essential to follow NEC guidelines for proper installation practices, including securing the wire with staples or cable ties and ensuring proper connections at outlets and switches. Secondly, consider 14-3 wire. This wire type contains 3 current-carrying conductors and a ground wire. It's often used for three-way switches, where one conductor carries the power to the switch, another conductor returns the power from the switch, and the third conductor serves as a neutral. It can also be used for split receptacle circuits, where one receptacle is controlled by a switch while the other remains constantly powered. Like 40-2 wire, 40-3 wire is rated for 15 amp circuits and must be installed according to NEC standard. The insulation and sheathing materials are similar to those used for 40-2 wire. Thirdly, we have 12-2 wire. This type consists of 2 current-carrying conductors and a ground wire, but the 12-gauge wire is thicker than 14-gauge wire, making it suitable for circuits with a higher current rating. 12-2 wire is commonly used for kitchen outlets, bathroom outlets, and other circuits that supply power to appliances or devices drawing up to 20 amps. The NEC allows 12-gauge wire to be used on 20 amp circuits. Proper installation is crucial, including using appropriate connectors and ensuring that the wire is adequately protected. Fourthly, there is 12-3 wire. Similar to 40-3 wire, this type contains 3 current-carrying conductors and a ground wire. It is used in situations where multiple switching options are needed, such as controlling a light fixture from multiple locations. It can also be used for split-wired circuits, providing flexibility in controlling different loads. 12-3 wire is rated for 20 amp circuits and must be installed according to NEC guidelines. Fifthly, let's look at 10-3 wire. This type consists of 3 current-carrying conductors and a ground wire, and is typically used for larger appliances such as electric stoves, dryers, or smaller air conditioning units. 10-gauge wire is thicker than both 14 and 12-gauge wire, allowing it to carry higher currents. The NEC specifies that 10-gauge wire is suitable for circuits protected by a 30 amp circuit breaker. Proper termination and connection are essential to ensure safe and reliable operation. Sixthly, we have 8-3 wire. This wire type contains 3 current-carrying conductors and a ground wire, and it's used for even larger appliances or subpanels that require higher current capacity. Examples include large electric ranges, water heaters, or air conditioning units. 8-gauge wire is thicker than 10-gauge wire, allowing it to handle even greater electrical loads. The NEC permits 8-gauge wire to be used on circuits protected by a 40 or 50 amp circuit breaker, depending on the specific application and insulation type. When working with any of these wire types, safety is paramount. Always disconnect power to the circuit before working on any electrical connections. Use appropriate personal protective equipment, including safety glasses and gloves. Follow all NEC guidelines and local electrical codes to ensure safe and compliant installation. When estimating the amount of wire needed for a house, consider the layout of the house, the number of circuits, and the types of electrical devices being powered. A larger house with more circuits will require more wire than a smaller house with fewer circuits. Additionally, consider the distance between the electrical panel and the various outlets, switches, and appliances throughout the house. Longer runs of wire will require more footage. Remember that these estimates are approximate and can vary based on specific factors. Consulting with a qualified electrician is always recommended to ensure accurate estimates and safe installation practices. It's also important to account for any special purpose circuits, such as those for HVAC systems, security systems, or home theaters, which may require additional wiring. The information provided regarding wire gauges and their applications is intended for educational purposes and should not be considered a substitute for professional electrical advice. Always consult with a licensed electrician for any electrical work to ensure safety and compliance with local codes. When considering the installation of electrical wiring in a house, it is important to understand not only the types and quantities of wire needed, but also the relevant safety standards and best practices. The National Electrical Code, or NEC, plays a crucial role in ensuring the safe installation and operation of electrical systems. The NEC is a comprehensive set of standards and guidelines that cover all aspects of electrical wiring, from conductor sizing and overcurrent protection to grounding and bonding. Compliance with the NEC is essential to prevent electrical hazards such as fires, shocks, and equipment damage. Several key articles and sections of the NEC are particularly relevant to residential wiring. For example, Article 210 covers branch circuits, which are the circuits that supply power to outlets, lights, and appliances. This article specifies the requirements for circuit sizing, overcurrent protection, and the number of outlets permitted on each circuit. Article 220 addresses load calculations, which are used to determine the appropriate size of the service entrance and the capacity of the electrical panel. Accurate load calculations are crucial to ensure that the electrical system can safely handle the anticipated load. Article 250 covers grounding and bonding, which are essential for preventing electrical shock hazards. This article specifies the requirements for grounding electrodes, grounding conductors, and bonding of metal enclosures and equipment. Article 300 provides general requirements for wiring methods, including the types of wiring permitted, the installation of cables and raceways, and the protection of conductors from physical damage. Article 310 covers conductors for general wiring, including the ampacity of conductors, which is the maximum current a conductor can carry without exceeding its temperature rating. This article provides tables that specify the ampacity of different sizes and types of conductors. In addition to these articles, there are many other sections of the NEC that are relevant to residential wiring, depending on the specific application. It's essential to consult the NEC in any applicable local codes to ensure compliance. When installing electrical wiring, it's crucial to use the correct tools and equipment. This includes wire strippers, crimpers, pliers, screwdrivers, and multimeters. Using the right tools can help ensure safe and reliable connections. Proper wiring techniques are also essential. This includes stripping the insulation from wires without damaging the conductors, making tight and secure connections, and properly terminating wires at outlets, switches, and circuit breakers. It's also important to protect wires from physical damage by using appropriate cable clamps, staples, and raceways. Grounding and bonding are critical for electrical safety. All metal enclosures and equipment must be properly grounded to provide a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Grounding electrodes, such as ground rods or water pipes, must be properly installed and connected to the grounding system. Overcurrent protection is another essential safety measure. Circuit breakers and fuses are designed to protect circuits from overloads and short circuits. It's important to use the correct size of circuit breaker or fuse for each circuit, based on the ampacity of the conductors and the load served. Regular inspection and maintenance of the electrical system are also important. This includes checking for loose connections, damaged wiring, and signs of overheating. Any problems should be addressed promptly to prevent potential hazards. Working with electricity can be dangerous, and it's always best to hire a qualified electrician for any electrical work. A licensed electrician has the knowledge, skills, and experience to perform electrical installations safely and correctly. Hiring an electrician can also help ensure compliance with local codes and regulations. Furthermore, they will often get an electrical inspection done to provide peace of mind for the homeowner. Understanding the basics of electrical wiring and safety can help you make informed decisions about your home's electrical system. However, it's important to remember that electrical work should only be performed by qualified professionals.